In this video, we are going to discuss about the Mos Logic families. So, on completion of this Mos Logic families, students will be able to describe the equation for source to drain current in the three regions of operation of the MOS transistor and able to draw the VA characteristics of MOS transistor. So first of all, we are going to see about the NMOS IV characteristics. So in NMOS IV characteristics, this is a 3-terminal device and there is no single IV characteristics in it. So here we have to note that because of this gate insulator, that is IG, we are setting as 0 amps. We typically define this MOS IV characteristics as ID versus VDS, that is for a fixed gate source voltage. Also, this NMOS IV characteristics operates in 3 modes of operation. One is triode mode, another one is saturation mode, and another one is cutoff mode. So in the case of triode mode, this VGS value gradually increases, and in the saturation mode it remains constant, and the cutoff region it is very low, that is VGS values will less than or equal to VTN value. And in this NMOS saturation, if VGD is less than VT, this channel pinch off near the drain, and also when VDS is greater than VDT, that is which is equal to VGS minus VT. Now this drain voltage has no longer increases current, so we define this IDS is equal to beta into VGS minus VT minus VD sat divided by 2 into VD sat, which we can simplify it as beta by 2 into VGS minus VT the whole square. So as I said, here we have 3 modes of operation. One is cutoff region, linear region, and saturation region. In the case of cutoff region, this occurs when this VGS value is very less than the threshold value, that we say as ID value is equal to 0. And in the triode mode, this occurs when VGS value is greater than the threshold value, and also VDS is less than the VGS minus this threshold value. So finally we write this equation as ID is equal to beta into VGS minus VT minus VDS by 2 into VDS. In the case of saturation mode, this VGS is greater than VTN value, and also VDS is greater than equal to the VGS minus this threshold voltage. So we write this equation, IDS is equal to beta by 2 into VGS minus VT the whole square. So here is an example for it. So here we are using 0.6 micrometer process for our project from the AMI semiconductor. TOX, mu, VT and IDS is given. So VGS we are increasing for 0, 1, 2, 3, 4, 5, and we are using the W by L value was 4 by 2 lambda. Finally we are substituting this in the beta is equal to mu COX W by L, and which is equal to 120 W by L mu A divided by B square. Next we are going to see about the PMOS IV characteristics. So this PMOS IV characteristics has a dot at the gate, but this NMOS does not have a dot at the gate. So this is the only difference between the NMOS and the PMOS. So here ID, VGS, VDS and VTH are all negative for PMOS. So these values are positive for NMOS. So here the channel formed will be when VGS is less than VTH, this is opposite for NMOS, and the saturation occurs when this VDS is less than or equal to VGS minus VTH, which we say as opposite for NMOS. And also, while considering this PMOS IV characteristics, here also we have 3 modes of operation, that is saturation mode, triode mode, cutoff region, but this occurs in the negative side, that is VGS value will be minus 1 volt or minus 2 volt or minus 3 volt. So this dopings, all the dopings and the voltage are inverted for this PMOS. Mobility is determined by the holes, and also typically here we have 2 to 3 lower than the electrons. So thus this PMOS must be wired to provide the same current. And in this PMOS region, we can say this cutoff region occurs when VGS is greater than or equal to VTH, that is ID is equal to 0, and triode mode which occurs VGS is less than or VTH and VDS is greater than VGS minus VTH. And the saturation mode, this VGS value is less than VTH and VDS is less than or equal to VGS minus VTH. So these, since this lambda is very small or 0, this is constant in the saturation mode, so we call this current as ID sat. So quiz questions on Mos logic families. First, draw the DC transfer characteristics of CMOS inverter. Implement the RC delay model of the Mos transistor. Thank you.